So, folks, we've been talking about empirical formula for the past few days. All right. What is an empirical formula? Simplest whole number ratio, right? So it's the most simplified formula that we can have. Do you think that all formulas are going to be simplified, though? No, we've seen examples already in our naming unit, guys, where we had, especially covalent compounds, something like N2O10. If I were to write that in here, N2O10. Yeah, we can do that, something like that. Can we simplify that? How would we simplify that down? N105, right? That's what it means to have the simplest whole number ratio. It would be something like that. We don't need the one there, right? What'd you say? Yeah, the first one, guys, is the actual formula. Then this one is the empirical, where we simplified it. But not every formula will be simplified. All right, so that's where this thing called molecular formula comes in. All right, and that's what we call, quote unquote, the actual formula. All right, so you want to highlight that in your notes. All right, molecular formula means the actual formula. That's kind of the way to think about it. Now, I will say this, and it may be confusing. So just before you be like, what do you mean? Just think about it for a second. Guys, empirical formulas can be molecular formulas, or molecular formulas can be empirical, but they may not be the same thing. It's kind of like saying all thumbs are fingers, but not all fingers are thumbs. Have you ever heard that before? All squares are rectangles, but not all rectangles are squares. Same idea, right? Same thing here, guys. Empirical formulas can be molecular. They can be the same, but they don't have to be. All right. So you see the example here. Molecular formula is C2H6. The empirical formula then is broken down and simplified to just CH3. All right. So we can. Why they're not necessarily the same. All right, is empirical again is that simplified. We get that from the percent composition. If we're given percent composition of an element, we can then calculate the empirical. But to figure out the molecular, we have to be given the molecular mass. So how these two pieces are related is down here. We're looking for X in this little formula. Molecular formula, guys, MF equals molecular formula. EF equals what? Empirical formula. All right. So X, guys, is a subscript that's on the outside of parentheses that go all around and encompass the empirical formula. All right. X, though, is just a ratio of the molar mass of the molecular compound to the empirical mass. All right. So the molecular mass, and we get that. The molecular mass. We will be given the molecular mass. All right. We have to be given this in this class. All right, so in a problem, you will be given the molecular mass, and you have to see how it relates to the empirical mass. Now, empirical mass, do we have to necessarily be given that? No, because we can be given the what to get the empirical mass? We can either be given the percent composition. All right, so there's kind of two things, guys, we can be given. We can be given the percent composition, and then what will percent composition get us to? Help us find out the empirical formula. All right? So that's really what we need, guys, is the empirical formula. Whether we have to calculate the empirical formula or we are given the empirical formula, then we can get the empirical mass. Because all this is saying, to get the mass, guys, we're going to take the molar mass of the empirical compound. All right, the empirical formula. That's simple. We've been doing that for over a week now. All right? So it's one of two things. From there, once we get our ratio of how the molecular mass relates to the empirical mass, then we go back, we plug it in as a subscript. What do all subscripts do on the outside of parentheses? They distribute in, and they change the subscripts of every piece inside. All right? Again, nothing really brand new here, guys. The concept is new, but the math, we've been doing this math for a while now. All right? We've been doing it all last week, and even before in our naming unit, all right, nomenclature. So let's just jump in here to a problem. It says, empirical formula of a compound was found to be P2O5. Raise your hand and tell me the correct name of that compound. I'll give you a prize. Brian? Diphosphorus pentoxide. There's going to be a lot of opportunities for prize questions with naming here, so be ready for when I ask those. Experimentation shows that the molecular mass of this compound is 283.89 grams per mole. What is the compound's molecular formula? Guys, there's a lot of information here we got to think about. This is where we starts to get very important that you write down what's important. So what's one piece of information that's important here? All right, molar mass. But not just molar mass. What mass is it? It's the molecular, guys. So now, molar mass is a general term. Now we have to specify which mass it actually is, because we're going to be looking at two masses, the molecular mass and the... What's the other one? We just looked at it in the last one, guys. You have it in your notes right there. Empirical mass. We have two different masses we have to distinguish. So this is the molecular mass equals 283.89 grams per mole. All right. What else are we given in this problem? What are we looking for? We'll need the empirical mass, but what are we looking for in the end of the problem? Yeah, guys, we're looking for the molecular formula. All right, so that's what our target goal is to get to the molecular formula. There's another piece that we're given you guys are overlooking. What else are we given in this problem? Yeah, what is P2O5? That's my what? That's my empirical formula, guys. We're given the EF, the empirical formula, which equals P2O5. So if we look back, I'll move back to that slide again, guys. We need to figure out the molecular mass ratio compared to the empirical mass, because then we can figure out what X is, which will allow us to manipulate the empirical formula however we need to. So, molecular mass I'm given. Am I given the empirical mass? Can I get it? How do I get it? Periodic table is going to be a tool I'm going to use. But what piece, guys, that I have written down already is going to help me figure out the empirical mass? The empirical formula, guys. So, to get the empirical mass, I first need to get the molar mass of my empirical formula. So, go ahead and do that. We should know how to do that very easily by now. Phosphorus, oxygen. Give you guys 20-30 seconds to calculate that, so go ahead. All right, so when you multiply out phosphorus, guys, what do you get for the total phosphorus mass? 61.94. Oxygen is 80. Add them up, our total mass is? All right, so guys, there's our empirical mass. 141.94. So now all we have to do, guys, is figure out what X is. X equals molecular mass over the empirical mass. All right. Just finding a ratio, comparison between those two. Molecular mass 283.89. But we shouldn't need to worry about putting units on that because we're not going to have units in the end because grams per mole will cancel out for both of those. So empirical mass is 141.94. When you do that math, what does X equal? X equals 2. So now, we're going to go back to our empirical formula. Let me erase this here so I have some space. So P2O5, guys, right here, my molecular formula is going to equal this. We distributed it in. What's my molecular formula going to equal in the end? P4O10. Raise your hand. I'll give you a prize and tell me the correct name of that compound. Darius? Yep. Tetraphosphorus decaoxide. Absolutely. Guys, is this completely brand new to us? No, it's taking what we already know, what we've already gone through, it's adding one extra step. The only new step is right here, where we look at that ratio between the molecular mass and the empirical mass. The hardest part about this is distinguishing and labeling and keeping them separate, guys, knowing which one is which and knowing what those two terms mean. All right? Questions? All right, I want you guys to do the first two examples that are in your packet. First one is this one. The empirical formula of a compound is NO2. Its molecular mass is 92 grams per mole. What's the molecular formula? I want you to do that. And number 2 that are right there in your notes. We're going through this. First step is to do what? Write down what you have. We have an empirical formula in this problem. of NO2. Molecular mass given to us, so you're going to check your work. 92 grams per mole. What's the molecular formula? So these problems, guys, aren't too bad. All we need to do is figure out the empirical mass. And how do we do that? Well, get the molar mass of our compound. So nitrogen, 14.01, plus oxygen is what? What's the mass of oxygen? 16 times 2 is 32 is what we get here. So our total molar mass of our empirical compound is 46.01 grams per mole. So all we have to do then, guys, to figure out X is take the molecular mass, in this case is 92, divided by 46.01. Now when you do that math out, you get something like 1.99. So what do you think we're going to do here with this one, guys? We're going to round it to 2. What if you had something like 1.5? Would you round it? No, that's where you would multiply, just like with empirical formulas, guys, where you have like 0.5 or a quarter or 3/4 or so on, those kind of 5 numbers you need to know for your test on Thursday. You would multiply to get to the whole number. You should not, in this class, guys, have to worry about that with molecular. But if you had that case, you would multiply. So X equals 2. I'm going to take molecular formula equals my empirical, which is NO2. Multiply by 2 here. Subscripts distribute in. So my final molecular formula is going to be what? N2O4. Prize, you can raise your hand and tell me that name. Anna? Dinitrogen tetroxide, absolutely. All right, any questions on number 1? Easy? I'm going to go a little bit quicker here, guys, with this one. So I've written down all the information that I've taken out of the problem here. I didn't have the words on my slide. I apologize for that. We need to find the empirical mass first. All right, CH2, that's 12.01 plus 2.016, since we had 2 hydrogens. So we get 14.026 is what you'd have for your mass there. Really, that's basically 14. So when we figure out X, we take 70 divided by 14.026. When you do that math, you get what? No? 4.99. What's that going to be equal? 5. So again, molecular formula equals our empirical formula, which is CH2, 5 subscript, distributed in. Our molecular formula then is? Another prize question. Raise your hand and tell me. Correct name of that compound. Claire. Hydride. Pentacarbon decahydride is what you would have there. Now there's other ways to name it as well, but for this class we're going to go with that. All right, guys, now take a look here at the last example on your sheet. How does this differ from the other two? It's got percentages. So what's the extra piece we're going to have to do here? You have to first find the empirical formula. It's not given to you, so you got to go through that process. And then from your empirical formula, guys, you will figure out what the molecular formula is. So I'll give you guys a few minutes. You're going to calculate the empirical formula first. Then go through and finish the problem. While you're doing that, I'm going to pass back quizzes. Check your work. What's our saying, folks, to help us with empirical formula process? Percent to mass. Mass to... Absolutely. You get a little dance going there too, Alex. Percent to mass, mass to mole, divide by small times whole. Guys, I'm telling you, commit that to memory. Be able to write that down in your test on Thursday. Be able to draw that roadmap that is on the board on your test. It's just going to make it so much easier for you. So here we go. Percent to mass is easy. Alright, so getting it to moles first, we can't compare masses. When you do this for carbon, you should get 3.33 moles for carbon. Hydrogen is it 6.67? 6.5? Yeah, okay. 6.5 moles of hydrogen. You should end up with 3.34 moles of oxygen. Now, folks, so a lot of people as I've been walking around so far today, they're skipping the next step. And this is the one I've said all along that people forget. We get percent to mass, mass to mole. Then what's the next saying? Divide by the smallest. All right, because right here, guys, are moles. We're trying to get a ratio to compare them. How they compare. 3.33 is there. Is the smallest. When you do that, you get 1 for hydrogen, 2 for 1 for carbon, 2 for hydrogen, and then 1 for oxygen. So my empirical formula, guys, that gives me my empirical formula, which equals CH2O. Now, I'm looking for the molecular formula. But I'm given the molecular mass is 60 grams per mole. All right, so I need to find my empirical mass. Add those up. When you do that, you should end up with about 30 grams per mole for your empirical mass. So to get that, we need to get X equals 60 divided by 30. And what does that equal? X equals 2. So my molecular formula then would be C2H4O2 is my molecular formula. If you get some random weird-looking numbers, guys, for an empirical formula or whatnot, you probably skipped a step. All right, it should not be something in this class where it's like C3H14O7 or something crazy like that. All right, it's going to be pretty basic. Don't overthink, guys. If you get something crazy, go back and check your work. Yes, ma'am. Right, no, we will not simplify it, right, because molecular formula is the actual formula. We only simplify when we're asked to. That's why, guys, maybe you notice on the naming test, some of the molecular formulas that we had were like N2 or like N4H10. You didn't simplify those on your naming test. All right, we name those. It's ionic formulas. The ionic compounds are the ones we simplify. All right, when we talk about empirical formulas, it's mostly, not all, most of them are covalent, or the ones where they won't be simplified really are covalent. Ionic ones will be the ones that are simplified. All right? Questions? All right.